Hello friends, I Professor Darshan Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for this subject head network theory. So friends, as far as this network theory is concerned, so in this subject head with the help of this video lecture series we will try to learn the different fundamental concepts involved in case of this network theory. Means whenever it is required to analyze the given circuit, either AC circuit or DC circuit, so at that time there are so many number of strategies we are having with us through which we can analyze that circuit. Analyze that circuit means whenever we are interested to determine the desired current flowing through in that particular branch, so at that time there are so many strategies by which we can determine the desired current flowing through or the ohmic drop across each and every branch, right? So as far as our today's session is concerned, so we will try to learn the basic techniques which involves in case of this network theory, whose name is nothing but what, as you can see, the mesh analysis, right? So first of all, one question arises in our mind ki why we are going for such type of network analysis technique, right? So the answer for this question is nothing but what, let us quickly go through the objective for our today's session is nothing but what, such type of network we used to have with us, right? Network in the sense what kind of network it is. Basically it is pure DC network we are having with us. A finite number of elements we used to have within that network, and as far as this number of elements are concerned, so we are interested to determine the current flowing through this 2 ohm of resistor. That is our objective. We are supposed to determine the desired current flowing through this 2 ohm resistor by using this mesh analysis, right? So first of all, we need to understand the basic concept of this mesh. So basically mesh is nothing but what, it is a close conducting path, just similar to the loop, right? So by taking into account the basic definition of this mesh terminology, we are in need of one circuit analysis technique whose name is nothing but what, the Kirchhoff voltage law. By using this Kirchhoff voltage law, we can determine or we can adopt the basic strategy belongs to this mesh analysis. So first of all, we need to recall the basic strategy of this Kirchhoff voltage law, right? According to this Kirchhoff voltage law, actually the circuit analysis technique was invented by this fellow. So on behalf of his invention, the name given to that technique is nothing but what, the Kirchhoff voltage law. So this Kirchhoff voltage law states that, or according to this Kirchhoff voltage law, the algebraic sum of ohmic drop across each and every element belongs to that closed conducting path are equated to 0. That we need to use this Kirchhoff voltage law in case of this mesh analysis technique. Okay friends, so according to this Kirchhoff voltage law, as I told you earlier, the algebraic sum of all ohmic drop belongs to that closed conducting path are equated to 0, right? Means first of all what we need to do in this mesh analysis method, the most important thing which we need to understand ki, from sake of observation, first of all we need to decide ki how many number of closed conducting path we used to have in that given existing network, right? So this is how our network will look like, which consists of finite number of elements or the finite number of branches which are connected in shunt and in series with each other, right? So from sake of observation, first of all we need to look around ki how many number of energy sources we are having with us in this given network. So probably there are two energy sources, one is voltage source and another is nothing but what, current source. So in this existing network we are having two voltage sources. So this is the symbol of that DC voltage source. We don't have any current source which involves into this given network. Probably in next session we will try to discuss another example in which we are having one or two current sources along with that voltage sources, right? So as I told you earlier, first step which we need to do ki, from sake of observation we need to decide or we need to look around ki how many close conducting paths are there, right? So see, this is the first close conducting path, this will be the second and this will be the third, right? once we are coming on to this conclusion ki there are three close conducting path, or there are three identical mesh we are having with us, then the second step which we need to do ki we need to assume the fundamental currents belongs to each and every mesh, right? As we are having three different mesh, so accordingly there will be three fundamental currents, I1, I2 and I3. I1 belongs to first mesh, I2 belongs to second mesh, and I3 belongs to third conducting path or the close conducting path, right? Then after that, once these fundamental currents are being decided, which are based upon how many number of loops or mesh we used to have in that given existing network, then after that we need to assume the direction of current flow belongs to I1, I2 and I3, right? As we know, the natural direction of current is nothing but what? From negative to positive terminal. So opposite to that, first of all what we need to do, see, this will be the assumed direction of I1, right? This I1 flows in that first mesh in clockwise direction, that we need to assume, right? There are only two probabilities by which we can decide the direction of these fundamental currents, either clockwise or anti-clockwise or counterclockwise, right? So is it very convenient for we people to assume कि if there are three mesh, so all the fundamental currents flows in clockwise direction, or all the fundamental current flows in anti-clockwise direction, either clockwise or anti-clockwise, right? Which will reduce the further complexity of that circuitry in order to decide the desired branch current flowing through this 2 ohm of resistor, right? Now once it is being decided that this I1 flows in clockwise direction, in same manner this will be the direction of current belongs to I2, and this will be I3, right? So this is the most important step involves in case of this mesh analysis, is to observe how many number of mesh we are having, and once it is being decided, after that we need to look around how the fundamental current flows through each and every mesh, either in clockwise direction or in anti-clockwise direction. Once it is being decided, then after that, as I told you earlier, what we need to do, we need to apply this Kirchhoff voltage law to each and every mesh, right? According to this Kirchhoff voltage law, which says that the algebraic sum of all ohmic drop belongs to each and every element belongs to that close conducting path equated to 0. Their algebraic or the algebraic sum of ohmic drops are being equated to 0. This is the simple meaning which is coming out of from that Kirchhoff voltage law, right? So in that next step, what we need to do, we need to apply this KVL to that first loop, second loop and third loop, right? Now see, when we apply this Kirchhoff voltage law to that first mesh, so at that time we need to look around how many number of elements we are having within that first mesh. So as we know, this is the 10 volt battery, first element, a resistor of 6 ohm, second element, and the third element is nothing but what, a 1 ohm resistor, basically, which is connected in that vertical arm. When it is connected in vertical arm, so it is a part of first mesh as well as second mesh, right? So when we apply this Kirchhoff voltage law to that first mesh, so at that time by default we need to understand key the significance of this first mesh I1 is greater than I2. When we apply the Kirchhoff voltage law in that second mesh, so at that time while applying this KVL to that second mesh or to that second loop, by default the significance of this I2 is greater than I1 as well as it is greater than I3, and same thing happens in case of this mesh number 3 when we apply the Kirchhoff voltage law to that third mesh. So at that time the significance of I3 is greater than I2 as well as greater than I1, right? So such type of hypothetical assumption we need to understand, right? So when, as we know, this I1 flows in clockwise direction in that first mesh, right? Then after that, the second important thing which we need to understand is how this I1 circulate through this 6 ohm of resistor and through this 1 ohm of resistor, right? So these two resistors are usually connected in two adjoining arms. Either it is connected in horizontal arm or either it is connected in vertical arm. So if it is connected in horizontal arm, so circulation of current will be probably from left side to the right side or from right to left. These are the two only ways by which there will be a circulation of current through the element which is connected in horizontal arm, right? As far as the vertical arm is concerned, so the circulation of current is from top to bottom or bottom to top, right? So as we know, the 6 ohm resistor is connected in horizontal arm, so this current flows from its left hand side to right hand side. Then accordingly we need to mark the polarity to that resistor. Similarly, how this I1 flow through this 1 ohm of resistor? The assumed direction of I1 is clockwise, right? So this clockwise current flow through this 1 ohm of resistor from top to bottom, right? Then we need to apply this KVL to that mesh number 1, right? As a result of applying KVL, what will happen when we start our journey with this 10 volt of battery? Now, how to map this 10 volt of battery in that Kirchhoff voltage law strategy? See, this is how the battery look like. This is the positive and this is the negative terminal, right? So when we are going from negative to positive terminal, obviously at that time the total polarity of that battery or the positive polarity we need to consider, right? Because we are following which direction? Clockwise direction. So while considering this clockwise direction, we are going from negative plate to positive plate. That's why the overall polarity of this 10 volt battery is plus 10, right? Now the I1 flow through the 6 ohm of resistor from left to right, right? As we are going from positive to negative plate, right? So the overall polarity of this ohmic drop across the 6 ohm of resistor will be negative. So according to that Ohm's law, ohmic drop equals to what? V equals to I into R. So which current flow through this 6 ohm of resistor? I1, right? So the overall ohmic drop across the 6 ohm of resistor will become what? Minus I1 times of 6. Now the question arises ki why negative sign is being taking into account? Because the assumed direction of current is clockwise. This clockwise current flows through the 6 ohm of resistor from left to right, right? So from, as we are going from positive to negative plate, that's why the negative sign is being taken into account. So it will become minus 6 I1. In same manner, again we are going from positive plate to the negative plate while considering the ohmic drop across this 1 ohm of resistor. Now another interesting thing belongs to this 1 ohm of resistor is nothing but what? It is a part of first as well as second mesh, right? So how the ohmic drop is being taken into account? As we are going from positive to negative sign denoted by this minus, right? The value of that resistor is how much? 1 ohm. And which two fundamental current flow through this 1 ohm of resistor? I1 as well as I2. But as I told you earlier, when we are in first loop, so at that time significance of I1 is greater than I2. Now how I1 flow through this 1 ohm of resistor? From top to bottom, right? Because the assumed direction of I1 is nothing but what? Clockwise. Now similarly, carefully you just try to see the assumed direction of I2 is also clockwise. But how this I2 flow through this 1 ohm of resistor? From bottom to top, right? From bottom to top. So this will be positive and this will be negative. Means the current direction of I1 as well as I2 are opposite to each other. How I1 flow through that 1 ohm of resistor? According to this clockwise direction from top to bottom. And how I2 flow through this 1 ohm of resistor? From bottom to top, as they are as their directions are opposite to each other. That's why the overall ohmic drop across this 1 ohm of resistor will become what? Followed by this negative sign, I1 minus I2, right? How I1 flows? Top to bottom, clockwise direction. How I2 flows bottom to top clockwise direction, as their current direction are opposite to each other, denoted by this negative sign. And what is the impact of this multiplier negative sign here? This negative sign indicates that I1 flows from top to bottom. As we are going from positive to negative plate, opposite sign we need to consider. So that is nothing but what? Negative. Now we don't have any further element which is present into that mesh. So equals to 0. This is KVL, right? What that KVL says, that the ohmic drop across each and every element, or the algebraic sum of all ohmic drop, belongs to that close conducting path equated to 0. Then after that we need to rewrite that equation. Simple mathematical simplification or manipulation we need to do. So it will become 10 minus 6 times of I1. This minus I1 will get multiplied with this parenthesis. So it will become minus I1 into plus I2 equals to 0. So this equation will become 10 equals to, all these terms are being shifted to right hand side of this assignment operator. As a result of shifting, minus 6 I1 minus I1, it will become minus 7 I1 when it is being shifted to right hand side. So it will become plus 7 I1 minus I2. So this is our equation number 1, right, by applying the Kirchhoff voltage law to that mesh number 1. Now in that same manner we need to apply this Kirchhoff voltage law to that mesh number 2, right? In that mesh number 2, which fundamental current flows? I2. How the direction of I2 is being assumed in that earlier stage? The direction of I2 is, again, it is in clockwise direction, right? Now in that mesh number 2, there are how many number of elements we are having? That we need to count. So 1, 2 and 3. We are having only 3 resistors. We don't have any energy source which is present within that mesh number 2. There are 3 resistors. One is of 2 ohm, 3 ohm and 1 ohm, right? One more time we need to assign the polarities to these 3 resistors according to the assumed direction of this fundamental current, that is nothing but what? I2, right? The assumed direction of I2 is nothing but what? Clockwise. So how this I2 flows through this target resistance of 2 ohm. Why it is being called it as a target resistor? Because our area of interest is to determine I2 ohm, current flowing through this 2 ohm of resistor, right? So ultimately it is connected in horizontal arm. If it is connected in horizontal arm, so there are only 2 probabilities, either right to left or left to right. Now the I2 is considered as a clockwise direction, right? So obviously it flows from left to right through this 2 ohm of resistor. Am I right? Similarly, how this I2 flows through this 1 ohm of resistor, right? The assumed direction of this I2 is nothing but what? Clockwise. So obviously from bottom to top. This is positive and this is negative. What about this 3 ohm of resistor? How this I2, which is assuming clockwise direction, flow through this 3 ohm of resistor? Obviously from top to bottom. So these are the polarities which we need to mark, which plays a very important role when we apply this Kirchhoff voltage law, right? So one more time we need to apply this Kirchhoff voltage law, which says that the algebraic sum of all ohmic drops belongs to that current closed conducting path equated to 0. So the ohmic drop across this 2 ohm of resistor, according to that Ohm's law, V equals to I into R. So which fundamental current flow through this 2 ohm of resistor? I2. How I2 flow through that 2 ohm of resistor? From left to right, as we are going from positive to negative plate while following the direction of fundamental branch current belongs to mesh number 2, that is nothing but what? I2. So obviously the ohmic drop across this 2 ohm of resistor will become negative. So it will become minus 2 times of I2. Why this negative sign is being taken into account? Because we are going from positive to negative plate of that resistor. Opposite sign we need to consider. So it will become minus 2 times of I2. This 3 ohm resistor is connected in vertical arm. Means it is a part of mesh number 2 as well as mesh number 3. But when we apply the Kirchhoff voltage law to that mesh number 2, so at that time the significance of I2 is greater than I1 as well as I3, right? So by taking into account this fact, through this 3 ohm of resistor there will be a circulation of I2 as well as I3. First of all, we will try to look around how the fundamental current I2 flows through this 3 ohm of resistor, right? The assumed direction of I2 is what? Clockwise. So already it is being denoted that it flows from top to bottom. And how I3 flow through this 3 ohm of resistor? Because I3 is again also it is being considered as a clockwise direction. It will circulate in clockwise direction, right? So while circulating in clockwise direction, how it will flow through this 3 ohm of resistor? From bottom to top. Means again, the direction of current belongs to I2 and I3 are opposite to each other through that 3 ohm of resistor. Even though the assumed direction of I2 and I3 is same, that is nothing but what? Clockwise, but their circulation through this 3 ohm of resistor will be opposite to each other. That's why, see, while applying the Kirchhoff voltage law, the direction of fundamental current which we need to consider, it will flows from bottom to from top to bottom, positive to negative. As we are going from positive to negative plate, so opposite sign we need to consider negative, right? The value of that resistor is nothing but what? 3. Which current flow through this 3 ohm of resistor? I2 as well as I3, right? But they are not sharing the same direction. The direction of I2 and I3 are opposite to each other as we are in second loop. So I2 is greater than I3, so it will become I2 minus I3. The same thing happens in case of this 1 ohm of resistor. How fundamental current I2 flow through this 1 ohm of resistor? Already it is being marked key bottom to top. But at the same time, another subsequent current which flows through this 1 ohm of resistor is nothing but what? I1, because it is connected in vertical arm, right? It is connected in shunt arm. It is connected in parallel form, right? Means it is a part of first mesh as well as second mesh. But this I1 flows from top to bottom, and I2 flows from bottom to top. Again, their directions are opposite to each other. That's why negative sign we need to consider as we are having in second loop. So I2 is greater than I1, right? And again, when we are going from positive to negative plate, opposite sign we need to carry. That is nothing but what? Negative. It will become minus of the value of resistor is 1 ohm. So directly I can write here minus I2 minus I1 equals to 0. The algebraic sum of all ohmic drop belongs to each and every element which is present within that closed conducting path equated to 0. That is nothing but what? Kirchhoff voltage law. Then after that, again we need to simplify this existing step equation. So as a result of this, it will become minus 2 times of I2. This minus will get multiplied with this parenthesis, so it will become minus 3 times of I2 plus 3 times of I3. Then similarly, this minus I2 plus I1 equals to 0. So how many terms we used to have belongs to I1? There is only one term. So this equation will become I1. How many terms belongs to I2? 1, 2 and 3. So minus 2 minus 3 minus 5 and minus 1. So it will become minus 6 times of I2. How many terms we are having belongs to I3? Only one term. So plus 3I3 equals to 0. So this is our mesh equation number 2. Right. In same manner, we need to apply this Kirchhoff voltage law to that mesh number 3. So how many elements we are having within that mesh number 3? There are 2 resistors and one energy source, a battery of 20 volt. Which fundamental current present within that mesh number 3? That is nothing but what? I3. The assumed direction of I3 is again it is clockwise. So how this clockwise I3 flow through this 10 ohm of resistor? Now even though this 10 ohm of resistor is connected in vertical arm, but purely there will be a circulation of I3 through this 10 ohm of resistor. It has nothing to do with I2 as well as I1 or any subsequent current, right? Because this is the last branch of that network obviously, or the circuit, right? So pure I3 flows through this 10 ohm of resistor. How I3 flow through that 10 ohm of resistor? I3 is clockwise, so obviously from top to bottom, right? How this I3 flows through this 3 ohm of resistor? When it is being considered as a clockwise current, so obviously from bottom to top, right? This 3 ohm is connected in shunt arm. It is a part of mesh number 3 and mesh number 2. Which fundamental current belongs to mesh number 2? I2. The assumed direction of I2 is again clockwise. So how it will flow through this 3 ohm of resistor from top to bottom. So this is positive and negative. Means one more time, the direction of I3 and I2 are opposite to each other. That's why we need to consider the negative sign, right? So the first element which we need to consider when we apply this KVL to the mesh number 3, right? So at that time what will happen? First element, that is nothing but what, 10 ohm of resistor. We need to declare the ohmic drop across this 10 ohm of resistor. According to that Ohm's law, V equals to I into R. So which current flow through this 10 ohm of resistor? I3. As we are going from positive to negative plate, so opposite sign we need to consider minus 10 times of I3, right? Now we are having we are encountering with this voltage source of 20 volt, right? We need to follow the direction of assumed current. The direction of assumed current is a clockwise direction. So according to this clockwise direction, we are going from this positive to negative plate. So opposite side we need to consider, so it will become minus 20, right? How about this 3 ohm of resistor? How this I3 flow through this 3 ohm of resistor? Bottom to top. As we are going from positive to negative, opposite sign we need to consider, so minus 3. But which two current flow through this 3 ohm of resistor? I3 as well as I2. As we are in third loop, so significance of I3 is greater than I2. So the equation will become minus 3 times of I3 minus I2 equals to 0. The algebraic sum of all ohmic drop belongs to that closed conducting path equated to 0. Then we need to rearrange this equation, so it will become minus 10 I3 minus 20 minus 3 I3 plus 3 I2 equals to 0. So we don't have any I1 terms. How many I2s we are having? Only one term. So it will become 3 I2. How many I3s? 2 I3s. So it will become minus 13 times of I3, and this minus 20 is being shifted to the right hand side of this assignment operator. As a result of shifting, it will become plus 20. So these are the three equations we are having with us, right? When we solve these three equations with the help of the scientific calculator, we will come to know ki the desired value of I1, I2 and I3. Then after that, we can determine, or we can decide which fundamental current flow through this 2 ohm of resistor and the desired value of that fundamental current. So I just hope that you had understand all these things belongs to this mesh analysis. Okay, so these are the three equations. First one is 7I1 minus I2 equals to 10. Equation number 2 is nothing but I1 minus 6I2 plus 3I3 equals to 0. And equation number 3, 3I2 minus 13I3 equals to 20. So as I told you earlier, with the help of this scientific calculator, we can solve these three equations to determine these three fundamental currents, I1, I2 and I3. So let us quickly go through how to solve these three equations with the help of this calculator. So first, once that calculator is being turned on, then you just go to this mode, press that key belongs to this mode. Then after that, we need to select this equation mode. So for that purpose, like this, once after pressing that key belongs to this equation mode, then how many unknowns we are having? As you can see, within that three equations there are three unknowns, I1, I2 and I3. So we are having three unknowns, 3, right? Now A1 means the coefficient of I1 in that equation number 1. The coefficient of I1 is what here? 7. So that we need to press. A1 is 7. Then next B1. B1 means the coefficient of I2. The coefficient of I2 is minus 1. So it is minus 1. C1. In that equation number 3, we don't have any term belongs to C. So it is obviously 0. And D, right? D1 equals to what? 10. A2 means the coefficient of I1 in that equation number 2. the coefficient of I1 in that equation number 2 is 1. B2 coefficient of I2 in equation number 2 is minus 6. C2 means the coefficient of I3 in that equation number 2, so it is 3. D2 equals to obviously 0. A3 means we need to collect the coefficients belongs to equation number 3. Coefficient of I1 is 0, means A3 is 0. B3 coefficient of I2, it is nothing but what, 3. Next, C3 coefficient of I3, it is minus of 13. D3 equals to 20. Then X is nothing but what, I1. This Y is nothing but what, I2. And Z is nothing but what, I3. Right. In this way we need to enter the coefficients of equation number 1, 2 and 3. Once all these three coefficients, all these equation coefficients are being entered, then this will be I1 and this is our desired current minus 0.61, which flows through this 2 ohm of resistor. Thank you. Okay friends, so once these three equations are being solved, equation number 1 is nothing but what, 10 equals to 7 I1 minus I2. Equation number 2 is nothing but I1 minus 6 I2 plus 3 I3 equals to 0. And equation number 3 is 3 I2 minus 13 times of I3 equals to 20. Right? When these three equations are being solved, so with the help of this scientific calculator, we are getting I1 equals to 1.34, I2 equals to minus 0.61 and I3 equals to minus 1.68. The unit for this current is nothing but what, ampere, ampere and ampere. Right. Now our objective was, we are interested to determine the current flowing through this 2 ohm of resistor. Right. Now how this 2 ohm of resistor is connected into that circuitry? This 2 ohm of resistor is a part of loop number 2. Right. It has nothing to do with this loop number 1 as well as loop number 3. Means which fundamental current is being considered for loop number 2? That is nothing but what, I2. Right. So this purely I2 flows through this 2 ohm of resistor. Means the current flowing through this 2 ohm of resistor is nothing but what, minus 0.61 ampere. So this will be the answer for this numerical. Right. So I just hope you had understand all these things belongs to this loop analysis. Thank you.